Welcome to General Mechanics Part 2. I'm Senior Airman Young, the 113th DCA National Guard, here at Joint Base Andrews. So today, we're going to go over gears and formula to help you figure out and solve some of those intimidating problems that you may have on your upcoming ASVAB testing. We'll break them down to show you how to get the answers to these problems. We'll also show you step by step how to get to those answers and how to weed out some of those wrong answers that may try to intimidate you to answer the question incorrectly. So, the first example of a problem that you see on the ASVAB is example number 425. The question states, if gear number 1 is moving counterclockwise, which direction is gear number 2 and number 3 moving? These are your choice of answers. Gear number 2 is moving clockwise and gear 3 is moving clockwise. Gear number 2 is moving counterclockwise, 3 is also moving counterclockwise. Gear number 2 counterclockwise, 3 clockwise. And then gear number 2 clockwise and 3 counterclockwise. The simplest way to figure out this problem is any gear that you start with, which will be gear number 1, the opposite gear always moves in the same direction. So in this instance, gear number 1 and gear number 3 are going to move in the same exact direction. So if gear number 1 is moving counterclockwise, so is gear number 3. So that weeds out option A and option C. Next, if these two are moving the same direction, the only other option is for this to move in the opposite direction. So, gear number 2 would move clockwise, and gear number 3 move counterclockwise. So your answer would be letter D. Gear number 2 moving clockwise, and gear number 3 moving counterclockwise. The second example, problem number 413, states if tank B, which is 6 inches wide, goes down an inch, how far up would tank A go, which is 3 inches wide? This is a very simple problem, however the answers are designed to confuse you. Tank B is 2 times the width of tank A. Therefore, if this goes down 1 inch, you just multiply that by 2. So tank A would go up 2 inches. So your answer would be option C, which is 2 inches. So the third example is problem number 419. The question states, if you remove the plug from the tube, which way will the water flow? Your choices and your answers are option A, it will flow into the tube. Option B, it will flow out of the tube. Option C, neither, it'll stay at the same level. Then option D, can't tell based off the information that you're given. The way to figure this problem out is to look at the diagram that you have. This level of water is higher than this level of water. So, the scientific way to solve this is that gravity takes into effect and everything must come down. If the water level in the tank is higher than the water level in the tube, when you remove the plug, the water level in the tube will rise. Thus giving you the answer A. The water level will rise into the tube if you remove the plug. Example number 415 gives you a little bit more in depth on the math portion of the ASVAB. This will basically show you how to solve a problem where there's multiple numbers and an answer that needs to be solved at the end. The question states, what amount of force is required to balance this entire shaft? Down here below, you'll see the formula written, but I'll go through it step by step. In the left portion of the shaft, you have a 5-pound weight at the end. Then you also have a 10-pound weight in the middle. If you look here, this is your formula. Okay, so what you would do, you would multiply the distance from the middle of the shaft times 5 pounds, which will give you 50 foot-pounds. Then you would also multiply this distance, 5 feet, times 10 pounds, which will give you 50. You add those two together, you would get 100 foot-pounds. Then you would do 100 foot-pounds divided by the total of 10 feet here, which would be 10 divided by 100, which will give you A. 10 pounds is the force that's required to balance the shaft. Example 401 gets furthermore in depth with figuring out how to solve a problem using an equation. The question states, if the barrel is 400 pounds, how many pounds an effort would it require to push it up the hill. So to figure this out, you would use the load, which is 400 pounds, divided by the mechanical advantage, which will give you the effort. To figure out the mechanical advantage, you would do the horizontal distance divided by the vertical distance. Therefore, 12 divided by 4 will give you 3. 3 is our mechanical advantage. We already have our load, which is 400 pounds. To simplify this question, 400 pounds divided by 3 will give you an effort. The options are 100 pounds, 133 pounds, 300 pounds, and 400 pounds. So, 400 divided by 3 gives you the effort, which would be 133 pounds. So the correct answer for 401 would be option B, 133 pounds. Question 418 states, when water is heated and confined to a closed container so that the steam can't escape, the pressure on the inside of the container will blink and the temperature of the boiling water will blink. Your options are as follows. Option A, the pressure inside the container will stay the same and the temperature of the boiling water will increase. Option B, the pressure inside the container will decrease and the temperature of the boiling water will increase. Option C, they both will increase. And option D, the pressure inside the container will decrease and the temperature of the boiling water will stay the same. If the container is closed, you can weed out any answer that says decrease for the pressure inside the container because there's nowhere for the pressure to escape. So option B and option D are out of the equation. Now you have options A and option C. If the pressure is inside the container and it is closed, the pressure will increase because there's no way for the pressure to escape. And the temperature of the boiling water will also increase. Weeding out option A, the option will be C, both of them will increase. So this concludes the second portion of General Mechanics. I'm Senior Airman Young, 113th DC Air National Guard, here at Joint Base Andrews.